What's up, guys? It's 8:35 in Utah. Just got in the office. It's a little chilly. I've got I'm speaking at a meetup tonight here at MX. Should be pretty fun. I love to speak. If you guys have never tried it, you should. Just find your nearest meetup about React or JavaScript, whatever you like, and do like a lightning talk or something. It's a lot of fun. I was wondering what I was going to talk about tonight. Clearly, I was going to talk about hooks or something like that. So I kind of wanted to practice my talk just a little bit with you guys. It won't go exactly the same. So if you're watching this and you're going to the meetup tonight, trust me, it will be a little different. It will be a lot better. But yeah, let's get into it. So just want to make sure that you guys can see this. I'm pretty sure you can. I'm actually going to pull out my phone really quick and make sure that it popped up right. Let's see. Sweet. And you can still see me. All right. See, just got to make sure because I can't see my other screen with Keynote. It's kind of weird. So, React hooks. Why are React hooks important? Why are they so good? And what's all the hype about? Really, that's the question. And if you already know about React hooks and you are excited about them, the next question is, when do you switch? And how difficult is it to switch? Let's get on with it. This is me. I actually just cut my hair, so I need to update that picture. But it was a sad day. But I also like my new hair. It's a lot easier to manage. That's my name, Tanner Lindsley. You can find me everywhere on the internet with my name. I like to talk. I like to chat. So come find me. I should probably add my YouTube logo to that, like the YouTube logo, so they know to come find me there too. So I have a startup. It's called Nozzle. I am one of 3 co-founders, and we make awesome software to track rankings across Google. And I just knocked my charger duck in the garbage. This little thing. Should not do that. Nozzle. We are an awesome company. We make awesome stuff. So you might be thinking, like, what is this hooks stuff? And you might not be buying it out of the gate. Somebody might have told you, well, you don't have to write classes anymore. And you might be like, what the heck? I don't know if that sounds legit or not. Maybe this is just like a stupid trend, or I don't know. A lot of people in the beginning were like, I don't know about this. But I'm going to convince you by the end of this talk that you need to use hooks and that they're going to make your life in React at least twice as good, maybe even more. So this is a pretty typical component you might see using a class. And if you actually look at all of the related logic in this class, which this is just like a greeting component, it's very arbitrary. But if you were to group all the things in this class that go together, you'd see some blue state up here for, let's see, that state. You'll see, let's see, what is that? Some name change handlers, and then you'll see where it's actually used down below. And it's like kind of all mixed in, like all the purple and the yellow, they all handle kind of different parts of this component. But they're all like separated into singular life cycles. And this makes it, I mean, it's worked up to this point, right? But this makes it kind of difficult to come into a component and just handle a single feature in one place. It seems like if you want to add one feature to a component, you're going to the constructor, you're going to all the lifecycle methods, you're going to the render. So this PRCHDK, this person came up with this awesome animation that shows how it looks when you change it to hooks. It gets reorganized into these beautiful blocks of reusable logic. And those blocks look like this, where a single input with its state can be managed here. The document title updating is managed here. The window width is managed here. And then you just kind of use them like functions. This is really important because this typical scenario, I think, can be intimidating for some people. You've got a constructor where you have to set up everything out of the gate and all these lifecycle methods you have to memorize. See right here, you're handling this timer ID, this set interval timer ID, and clearing it in two separate spots in the component. And it does feel weird now that I've tried hooks. And then, so once you see that in a hook form like this, it becomes much simpler to reason about. There's a function that sets the new date, and then there's this thing called an effect, where this effect gets run when the things inside this array change, and since there's nothing, it just kind of acts like component did mount and will unmount. So you can see the component gets a lot smaller, and our state becomes, it just becomes a lot cleaner. And this isn't too big of a difference, right? So let's move on to like a bigger difference. If you've ever seen this, I like to call this render prop hell. And basically, if you ever use render props or higher order components, you get into like this extreme nesting stuff where you need to get a value from one, pass it to the other, pass it to the other, and then finally, at some point, you'll have all of your values from all your render props. Well, if you use custom hooks, that can actually look like this. It's tiny. And it looks like it's synchronous because technically it is. We're going to get into more of that in an example that I'm going to show you guys. We're actually going to do some live coding on this, and it's going to be really fun to show you how that transforms. This next example is like change detection and memoization and data pipelining. This is how it looks before, right, in class components. You're using should component update to detect if the component should even update at all. You're looking at component did update to compare like previous and new props, and then if they change, you have to like, call your own methods to do certain things. You might even be using get derived state from props, where you're like ingesting props and then building new things inside of your component from those props, but only when they change. And then if you've ever done any type of memoization, memoization is a way to only run certain functions when their parameters change. So this memoize1 function down here is only going to run when these parameters actually change. So you can do this. It's tedious. You can see that there's kind of a lot going on here, and there's like 3 different ways to do things. But moving to hooks, this becomes more of a linear pipeline of change detection and performance and memoization going down the line. In this example on the right, you can derive data from your props and do change detection on those props at the same time. You can memoize. You can even memoize JSX and memoize child components and use your props or derived state to trigger those memoizations. And you can do that all in just a single render function. It's really nice for performance and creating pipelines of data that only update when you need them to. And then here's another one that's one of my favorites. This is a custom component that I kind of just made up, but it's actually kind of cool. It's called the promise fetcher. And basically, you render this promise fetcher with a function as a prop, and then another prop that it watches. And anytime that this other watch prop changes, it will run this function and kind of give you back this really great loading error result state that you can use, this refresh state. I'm going to show you guys how this transformation happens, but this is what that same component looks like as a hook. It's extremely small. In fact, I'm going to blow it up for you a little bit. All of that logic can fit inside of here. And it's so much easier to reason about and think about. It's fantastic. I can't wait to show you guys these 3 examples and exactly how those transformations happen, because I think once you guys feel what it's like to move from classes to promises, you're going to really feel the power. And if you're like me or anybody else on the internet or Twitter right now, this is how you're going to feel when you realize exactly what hooks can do for you. Yeah, so let's get to it. I really want to dig into this code really quick. Miguel Carvalho. I can't say your last name, Miguel, but hi. Hello. So let's hide this and get into some of the code. I only have 2 examples because I can technically show you all of those things that I talked about in the slides. I can show you just in 2 examples. This first one is actually taken from the the React.js docs. It's just a timer example, and you can see it's running right now. It says, "Hello world." It's 8:46 a.m. where I'm at. And the way it's doing this right now is with a class. It's we've got a constructor, and we have some default state here that we're setting the date to just a new date. And then down here in our render function, we're rendering this.state.date to local time string. And then we have some update logic here that's making it tick every second. And the way it's working right now is when the component mounts, it sets up an interval for a second. So every second it's going to be running this dot tick. And this dot tick simply updates the state with the new date. And then component will unmount happens right before the component unmounts, and it clears the interval so that we're no longer calling this interval after the component's unmounted. This isn't too bad, you know. Classes still work, and they work great. And this is actually pretty straightforward right here. We're going to move it to hooks. I'm going to show you what that looks like. First, let's see. I'm going to, I have a copy of it, so I just want to be able to compare. Let's move this over to hooks. So the first things first, we can move our state into what's called a useState hook. In fact, let's just make a function. We're going to leave this alone right here. We're going to make a function called app. Same function. We're just going to move stuff up here. So we need to establish some state. So we need to bring in a hook called useState. And we're going to call useState with our initial state. And it doesn't have to be an object in this case, which is really cool. But what it gives back is an array with the actual state that you gave it, or the current state, and we'll just call it date. And then it has a setter for that state. And since we only passed it the singular date, we can just say set date. This could be an object if we want. It'd feel a lot like the old state, this dot set state, but it doesn't have to be. So looks like we have taken care of that. Let's do our render function really quick. So we're going to take this out of there. Okay. And then this dot state dot date, well, we don't really have this in a functional component. And we have our state right here for the date, so we'll just do that. It's going to take our date right from there. And then we have this tick function. And this tick function, is what updates the current date, the current time. So we don't have this dot set state, but we do have a set date now. And it's not an object, so we don't need to pass this object structure. We can just do that. And here's kind of like our lifecycle components. Component did mount and unmount they can and did update. All of those lifecycle methods can actually be represented in a single, with a single hook called useEffect. So we're going to call useEffect. First, let's bring it in. useEffect. useEffect takes a function that runs, by default, it will run every single time after the component renders. So we'll start with that and just see. So this is actually going to present a problem right here. So this doesn't exist. So we'll just do a const timer ID for now. And this .tick, we don't need that because it's just tick now. We have our function up here. And then this is going to be kind of weird though, because right now, every time the component updates, it's running this function. It's creating a new interval every single time. You can see it's actually exponentially creating more and more intervals. Yeah, and it's quickly going to get out of hand. So we don't necessarily want to create an interval on every single time, but what we can do is we can pass some change detection down here as a second parameter. This is an array, and any object that we pass this array will get compared between the last render and the new render. And if any of these things change, then it's going to rerun this effect. Well, in this case, we only want to run it when the component mounts, and then remove it when the component unmounts. So actually, by passing an empty array, it will do just that. This empty array will tell this effect to only run one time, and then it will run the return function when we try and unmount. So now if we try and create this set interval, it's only going to do it one time, and we can verify that by every second we're just logging one hello, which is good. So this isn't running every single render. That's what we want. But we do want to take care of that component will unmount logic that we had before. So with an effect, what you can do is return a function that can unwind, or basically undo the things that this part of the effect did. Now, this clear interval, we don't need to use this because the timer ID is within our scope. So we're not sending through anything to watch, but we give it an empty array, so when it mounts, it runs this part of the function. And we return the unwinder. I like to call it the unwinder. I don't really know what it is, but it's kind of it's like the reverse side effect model, I guess you could call it. This is how to clear or undo any, safely undo anything you've set up in here. So we clear this interval. Now we have exactly what we had before. Yeah, I mean, let's compare. It's not that big of a difference in terms of lines or, you know, like complexity, I guess. But to some extent, it is easier to reason about, right? We say, okay, we have some state up here. It's a date. We can get it and set it. We have a tick function that updates the current date time. And then we have this effect. Well, anytime we use an effect, we say, oh, this is an effect, so we know that it's going to happen after every render or whatever. And then you can immediately look and see, hey, what are we looking for to change? And we're not looking for anything to change, so it basically acts like component did mount and unmount. I love this because this is taken straight from the reactjs.org example. My guess is in maybe a couple of days, maybe a week or two, hopefully very soon, this will be the new example for managing state in React, not the old class way. So we didn't get a drastic reduction in lines or anything like that. I'm just going to save this as index.new.js. Hey, we couldn't create the file. Well, that's weird. But anyways, it does help you reason about it better, and it creates a good foundation for more cool stuff. So this next example I'm going to show you is going to illustrate both the how to change a render prop component into a hook, and also how you can extract custom functionality into hooks. This one is actually going to be a really fun example. So right here I have this promise fetcher component that I told you guys about. This is how it looks when you use it. So you render the promise fetcher right here, and you give it a function that returns a promise, which in this case is just a fetch stuff function I made up here. This could be anything. It could be a call to a server, anything that returns a promise. But this fetch stuff function, what it does is it waits for a second, and then 20% of the time it will throw an error, but the rest of the time it will give us some stuff. And we use that right down here. And then this promise fetcher, I handed a watch prop that says whenever this thing changes, I want you to rerun this promise. I want you to rerun this function. And then underneath that, as a child function, we get all of this stuff. So it gives us the loading state, if there was an error, it gives us the result, and it even gives us a function called refresh that we can call manually if we want. And right now I have it set up to watch this little counter I've set up. We've got some state with count, got a little increment count method here, and it sits on this button. So every time that we increment the count, it's going to run that function and give us all this loading state. So you can see when it's loading, it shows the loading. Sometimes we get an error, 20% of the time in fact, and most of the time we get some stuff. And then we have this button inside of here that we can manually refresh that. Now that's not incrementing the count, that's just manually rerunning this promise and giving us loading error and a new result. So it's slightly contrived, but most examples are. And I want to show you how this promise fetcher component works right now using the class structure. So as a class, this promise fetcher component needs some state, needs loading, result, and error state. And then what we're doing is we are rendering the children as a function, and we're sending through this loading, result, and error state. We're also sending through this refresh function that comes from the class instance method right here. And this refresh function will get the function that the user passed the component from props. First it sets the loading state to true, and it nulls out any errors. And then it tries to await that function. And if it succeeds, it sets the result with the function's result. If it errors, it sets the error with the function's result. And really right here, yeah, it sets the error with the function's result. And then we have a finally clause here at the bottom that finally stops the loading from happening. It sets the loading state to false. And then this is our lifecycle stuff up here. So when the component mounts, we want to trigger it right away. So we call this.refresh as soon as the component did mount. When the component updates, we don't want to rerun our function every single time that the component updates or renders. That would be ridiculous. So we use the watch prop, and we compare the previous watch to the new watch, and if they're different, we call this.refresh. And that's why when we increment the count right here that we're sending through to the watch prop, it reruns the fetcher. So it's contrived, but this is actually pretty cool. This promise fetcher component isn't so bad. I whipped it up just a few minutes before I prepared this, and honestly, it's pretty cool, I think. But it could be cooler with hooks. And this is where I want to show you exactly how how to transform this into hooks. Let's do this. Let's make sure that I save. Let's make sure that I save the old version over here. And let's just get to it. So first things first, this fetch stuff function doesn't really need to change. That's just kind of our mock for some type of server promise or whatever. But this promise fetcher and the way that we use it down here, this gets interesting because React hooks, the API, doesn't give us, like a promise fetcher. Like, how are we going to use that as a hook? Well, technically, you can turn anything into a hook if you want. This is called building a custom hook, and that's exactly what we're going to do. So we're going to treat this promise fetcher like it's just a function that can use hooks. So let's do that. Let's create a function, and instead of promise fetcher, we're going to abide by the hooks, the rule of hooks guidelines that the React team has given us. And that is that all hooks usually start with use, and then it's use something. We might as well just call this use promise. So use promise, and we can usually directly translate props over to just arguments that come in on these hooks. So I know one thing we're getting in here is the function that we want to run. And the other thing is we're getting the watch, like whatever we're watching. And since we're only sending through two things, I'm actually just going to do them in order like this. Okay, so same as we did with the old counter, we're going to just start transforming this class over to a function little by little. So this state right here is actually probably going to be easier to manipulate if we use individual states. So we're going to create one for each part of the state. We need to bring in our use state from React. And I know we're going to have to bring in use effect eventually too, because we have some lifecycle methods. Okay, and then we need one for result and error. So we'll do result, set result, error, set error. And we're going to start all of these off just as null, just like they're doing right here. And I like to say, okay, we're done bringing that part over, so let's get rid of it. I like to do lifecycle methods last when I'm bringing things over. Usually setting up initial state is the easiest thing to do. The next thing I like to do is jump to the very bottom and just bring the render over and get rid of the render. So right here, we are just returning, returning children with all of this stuff. Well, we don't really have children here, but we don't need it because we're not in a render context for this hook. Technically, we could just return this stuff. And I don't know if you've noticed, but the way that use state returns its actual state variable in the setter as an array is kind of cool, because then we can name them whatever we want without doing something like loading and then like or it would be like state, and then we'd have to do loading, and then we'd have to do set state, and then we'd have to do set loading. Like, that gets kind of monotonous in my opinion. And I think that's why they did it this way. So I want to do the same thing in my use promise hook as well. I'm going to just return an array that just out of the gate gives you the loading state first, then the result, then the error, and then the refresh function. Now, we don't have this anymore, so we need to get rid of that. And if we don't have this, then pretty much all of this stuff goes away. We don't have refresh yet, and that's the next place I like to go to, is find any non-lifecycle methods and bring them over. So this refresh, we're just going to cut out of there. We're going to bring right here, we're just going to const refresh. This is a refresh function. Then we're just going to go through the refresh function. it's trying to get our function from props. We don't have props anymore, and we don't need to get it because we already got it right here. So now it's in scope. This dot set state, well, we don't have this anymore. And technically, all of these are individual set states now too. So we can just do set loading true, set error null. We can get rid of this one. And then set state result, so we can just say set result right there. Let's see, this would be set error, and get rid of that one. Set loading, false. Okay. All right. There's nothing left. Oh wait, no, we have our lifecycle methods. This is why I like to do these last. So let's pull these out of here and just bring them in here, paste them in here, and it's gonna be like, what? This component did unmount. Well, we know that use effect is the way to do lifecycle methods. And it's because we need to start thinking in terms of effects and side effects instead of lifecycle methods. So let's just call use effect and give it a function. Out of the gate, we know that this effect is going to run every single time this function renders. Every single time this function is called, basically. We don't, well, no, it's not every time the function's called. It's every single time the component is re-rendered that we're using this effect in. We don't want that out of the gate. We didn't want it in the last one. We only, similarly to the clock, we only want to run this when certain things change. So we're going to need to pass an array of something. Let's move this out of the component did mount up to here. And we don't need this anymore. We just have refresh. And then, let's see, component did update. Well, what's the difference? Well, really there isn't a difference because this is going to run at the beginning, like when your component mounts, and any time that it re-renders. So we can actually reuse effects for that same purpose. So this is where it gets interesting. Before, we were saying, well, the component did update and it gave us the previous props. Well, what are we watching? We're watching the watch prop. Well, that's exactly what this array right here is for. If we just put in the watch prop right there, then anytime that this thing that we're passing through changes, it's going to rerun this function. And it's going to do that when it mounts, because before it mounts, there was no watch. After it mounts, there is a watch, so it's going to run. And then when we increment the count, this is going to go from 0 to 1. So it's going to rerun this again. And it's going to keep doing that throughout the life cycle of our component. And we don't need to return an unwinder for this one. We could do some unwinding like canceling the promise, but we don't technically need to do that right now. So this is where it gets cool. Before, if you look at the old version, we only had one prop where we could watch something. We could have put in like a watch 2 over here, like so it could watch 2 things. Or we could have passed an array in here and then we would have had to compare several things, like a deep compare. But we actually get a little bit more using the use effect hook. So instead of being able to just pass through one thing, why don't we just have whatever the user passes through right there be the watch? And then just so we don't get into an infinitely looping refresher here, we're going to default this to an empty array. So that if the user doesn't pass anything at all, it's just going to do it when the component mounts. That's it. Okay, our promise fetcher component is gone. And we have this new use promise hook. And it's a custom hook that we've created because it uses hooks inside of it. And we can use it anywhere in our app now. So we're going to come down here, and we're also going to convert this app over to a new function component using hooks. So we'll do function app. It has some state for the count. So we'll just use state, and we'll start it at 0. So we can get rid of that. It's got an increment count function. We don't have this or set state, but we do have set count. Similarly to set state, this takes a function to update the state. And it's very important that you always return the full state, not just a partial update, because use state updaters replace the entire state. They don't append to it like the old this.setState does. So you have to make sure that if you're using an object right here and doing it kind of like the old object set state, that you're returning the entire thing or decorating it like this. Like if we were doing it the old way, you'd have to spread old and then say count old.count plus 1. But since we're just using a primitive in our use state right here, we can just update it like this. Okay, let's see, we're not going to need that. Let's move our render function up here and get rid of our app component. And then this promise fetcher is now going to be a hook. So before we do that, let's get rid of any thises. So increment count is just a function now. Okay, so let's see, use promise. What are we passing to use promise? Well, we're passing the function and anything that we need to watch. So let's pass fetch stuff, which is the function that we want to call as the promise. And then we're watching count. Let's pass it like this because remember we made it so that it can watch multiple things. So we don't need that anymore right there. This is what it's giving us back right here. So let's move it up here. And remember, we're now switching over to use the array destructuring syntax like this. So we have all this stuff up here now. Promise fetcher isn't a thing anymore, so we can get rid of that. And the child function it was calling isn't a thing anymore either, so we can get rid of that. And the refresh is working. Let's see, it doesn't look like the count is quite working as we expected it to. Set count, old count plus, old.count plus 1. See, we had the object, nested object state before. Well, now we don't. It's just old plus 1 like this. So now when we increment it, in fact, why don't we put our count right here, just so we have it. So now every time that we increment the count, it's passing through the count. Our use promise hook is watching those things that we're passing through, calling fetch stuff, doing all our little awesome state magic right here, and it's always returning us the loading result, error, and refresh that we can use in our app. So this is pretty sweet. That's how we just converted it over. I'm going to zoom out a little bit here so you can see what we went through. So this is the old one at 97 lines, plenty of nesting and methods and this.setState, 97 lines. And we go over to the new one and we're at 65. So we're at 2/3 the size. And in my opinion, just easier to understand. Functions are so much easier to understand than classes for me. I hope it's that way for you guys too. But this just feels so clean, and it opens up the possibility for so many other cool things. Say this say we didn't want to have the watcher functionality inside here. Say we just wanted to use a promise, and it wouldn't automatically do this for us. We could even extract that out. We wouldn't even have to pass through any watchers. And we could just do that on our own right here. We could say, you know what? When count changes, I want you to call refresh. So now we've taken the effect into our own hands outside of here. And so this is just a place that manages state for this particular promise function that we send through. So you can see how it's so composable. We can move things in and out at will. You know, and not a lot changes. And so there, we just created a custom hook, and we also just got rid of some nesting. You can see that instead of nesting these components inside of each other, we brought it out into a custom hook up here. And if we wanted to have a couple more custom hooks, we could just keep cruising right here instead of infinitely nesting down with render props or HOs or higher order components. So I hope this has been a great example. There's one last thing that's really cool that I kind of showed in my slideshow, but I didn't show you how to do in here. Obviously, you can do things like use React.memo is kind of the prescribed replacement for should component update for doing performance type things. But this is really cool here. Say we had some really expensive, say we had a really expensive component to render. Let's call this expensive component. And, you know, it returns some stuff, expensive stuff. Or it does a lot of expensive things. And you know what? We could actually simulate that by saying, let's for loop for let I is 0, I is less than, I don't know, 1,000,000. No, let's start with 10,000, and then I plus plus. We're not going to do anything in here because we're just going to simulate an expensive component. So we're just going to loop a bunch. We're not rendering that yet, but why don't we render that down here? Expensive component. Expensive stuff. So if we start cranking this up, yeah, see, we'll get some infinite loop protection. But what we can do in here is we can say console log doing expensive stuff. And let's open up the console. Right now, you can see, because of all the different set states and the loading states, it's re-rendering this expensive component quite a bit because, you know, we're incrementing the count. Every time we do that, it's going to do that. Every time that we change the loading state or the result state or the error state for any hooks that use it, it's going to render our expensive component. Well, maybe we don't want to do that every single time. There's two ways we could do this. If we control the expensive component, we could actually put this expensive operation in a memoizer inside of here and only run that expensive operation when things change. So why don't we pass through the count to this function, or to this component. So we get the count. Expensive count, and we'll say it's just count times 2. We'll pretend that it took a really long time to update that count. And then we only want to, if we were to do that inside of the expensive component, this is what it would look like. We could take all of this, and we could return use memo. And just like use effect, we can pass a watcher and say count. So when count changes, it's going to rerun this function. And it just returns a value of whatever we return in here. So every time that count changes, it's going to run this function, do expensive stuff. We need to bring in use memo. So let's see, above occurred, we got an error. Let's see what that was. Oh, objects are not valid React children. Well, of course they're not. So return div, return use memo. Well, I don't think that should be a problem. We are getting some kind of cryptic error. Let's see, use memo, console log, return div, expensive count. Let's see, what is this error? This is a good thing this is a dry run, because I'm doing this talk tonight and I want to make sure that I don't run into stuff like this. Let's see, objects are not valid. This occurred in div. Well, we're not returning an object anywhere. Returning use memo. Expensive count. Return div expensive count. Well, that's strange. Let's just return null right here and see if we're getting that error anymore. No. Use memo, expensive component. Let's see when the count changes. Expensive count times 2. The count's not an object. Let's do this with count. Doing expensive stuff with count. Okay. I don't necessarily know why it was erroring there, but that was weird. So we're going to refresh this. Notice the difference now. We went through a couple of loading states with our use promise hook up here. And you remember before it was saying do expensive stuff like 3 or 4 times on the initial mount. But in our expensive component, we're passing through the count. Instead of expensive component, we'll say expensive doubler, because that's what it's doing. It's doubling the count. Doubled count. So inside of here, and we don't need this, we were just kind of simulating that. But you can see it will only update. It will only update when we update the count. See, when the loading state for our use promise stops, it doesn't run this again. That's what's really nice. And right now, that is this expensive doubler sending through the count. We have control over this, so it's easy for us to use a memoizer inside of here. But what if expensive doubler was not a component that we control? And we know that we only wanted to re-render it when the count changed. Well, let's just say that the expensive doubler we don't have any control over it, and it always returns the doubled count. Let's console log here again. Doubling count. So see, we're back to the problem we had before. It's doubling count every single time it renders, right? It's running expensive doubler. Well, what we could do is we could do this. We could say const doubled count. We can use a memo inside of here, and we can actually return using this component right here. So we can render this component inside of a memo only when the count changes. So now we even get to control components re-rendering that we don't have control over. All this other stuff gets to re-render whenever it wants inside of this component, but we get to control with use memo when this component actually changes. In my opinion, I would use this way more than React.memo. React.memo is basically like using pure component. So that's how you can do performance optimizations with hooks right there. We're only using 3 hooks here: use state, use effect, and use memo. And to be honest, this experience is amazing. I wouldn't have it any other way. I've been using hooks now for about, just since they came out. I can't even remember. It's been a couple weeks, maybe a little over a month. Maybe more. But seriously, I have converted most of my code over to use hooks, and I'm not looking back. I think you can gain much more stability. You can have more expression over your performance optimizations. You get to avoid all the nesting, and you get to share these hooks, across your entire application, or even on GitHub if you want to publish your hooks to GitHub for people to use. Lots of people are doing that. There are so many other things that you can do with hooks too that I haven't talked about here. Hooks can be helpful with routing. They can be helpful, anything having to do with context, theming. They can be extremely helpful handling global state. A lot of people, including myself, have replaced Redux with handling global state with just hooks, with building your own little hook management system. You can use hooks to turn APIs like local storage or window height or size, or things that you otherwise would have had to have read imperatively. You can turn those into hooks and just have them auto update and become part of your app seamlessly. Hooks, and custom hooks especially, are where the power lies. And I think that if you guys can start using hooks now, you'd like it. Any new components you can write with hooks. And the new version of React hooks, as far as I know, the new version of React isn't going to have any breaking changes, so you can actually use hooks and classes alongside each other. Cats and dogs can coexist, but dogs are better. No, the hooks are better. I don't want to write another class again. This has been really fun. I hope you guys have enjoyed this. Let's see. Nope. There I am. Hope you guys have enjoyed this. This is my practice run for my talk tonight. I think it went well. Be sure to leave any comments of things you guys would improve or change, or things that you liked. And then I can rework my talk for tonight. I'll also record my talk tonight, hopefully, and post it so you guys can watch that later too. Thanks for hanging out with me, and we'll see you later. My OBS is not closing the way it should. It's frozen. Oh well. Force quit.